Welcome to the first part in a multi-part series on how to use our Python workflow manager, pyiron workflow. We'll basically walk through all the features and the core functionalities of pyiron workflow that can help you basically maintain your workflows better or write workflows that are efficient and reproducible. So what we can do is we can import the workflow object from pyiron workflow. And this workflow object acts as a single point of entry to all of the useful tools that we can use to write our pyiron workflows, and all of the tools required to basically get all the neat functionality that we can get out of it. So what we can do is we can start off with a basic Python function, which everyone knows how to write. Here I'm just going to use the classic example of Hooke's law. This Hooke's law function is going to take in a force and a spring constant, and it's going to return me a displacement calculated according to Hooke's law based on the applied force and the spring constant of the material. And it's going to return me the displacement. Okay, so that's how you define a Python function. Everyone knows how to do this. And to call it, we can assign some arbitrary variable constants. Okay, or zero force, spring constant equals spring constant, and we get 0.5, like we would expect. So to turn this function into an object that we can use in our workflows, we can simply decorate it with this app workflow.wrap.as function node, and we can run the cell again. And what we notice is that if we call this again, we now get a complex object as the return. And this complex object is a pyiron node. Okay. And to basically get this to run again, to get the expected result that we got from our function, we can simply call run, and we get it as well. Or we can also just run it with the parentheses, just open close parentheses like any normal function call. So this first part is an object, our pyiron node, and this second part is the calling of this function. Okay, and we get it again. So we can now basically say, if we assign this to a node, let's call it h. Sorry, h.run. And to access the outputs of our node, we can also say, for example, we return multiple outputs. We can go h.outputs, and we can see that this outputs is basically another object. It's a dictionary. And in our dictionary, we have a key called displacement, which is the output of our function here. Okay, so to access this displacement value that we calculated, we can go displacement.value, or we can also use it, we can also access it through a dictionary. Because as you saw, it was a dictionary. Oops, sorry. Okay, so those are two ways that you can use to access the output of a node. And whichever way you want to, it's completely up to the user. And what's important here is that you can also go with h, and you can see that this node has multiple inputs, it has a single output, and it also has signals that basically tell you the nodes that come afterwards. Currently there are none, or basically tells the parent workflow exactly what its state is, whether it's already ran or whether it's already failed. Okay, so that's that. And one common gotcha is that we do not support functions with multiple return statements. So if we simply copy this up over here, down here, and say now we want a conditional, and say if the force is greater than some arbitrary amount, we have a certain different equation that applies to calculate the spring, the displacement, because the spring constant is different if you hit the object, hit the material with a different force. And in these two cases, you'll want to write a branch return statement. This is going to be a faulty node. And we're just going to recycle the constants variables that we already have defined before. Okay, so as expected, it fails. And if we scroll all the way down here, we can see pass output can only pass callables with at most one return value, but AST.walk found two. And to fix this, we can simply use something quite simple. We can just use a middleman variable. Okay, so here, we can use displacement there. And this middleman variable now fixes everything. Okay, so if we only have one return statement, it should work as expected. And of course, we can always access the outputs that we need via the syntax that I taught you earlier. Okay. And one other neat thing is that you can always modify how you want to access this output channel, like this variable name. If you're a fan of short variable names, like here, let's assign this node now to this. The force is the force that we defined before. The spring constant K is the spring constant. And we decorate this. And so this displacement refers to the variable output. And we simply run it. Okay, and we can see in the v.output, this variable output is now called displacement. So we can rename our variables directly in the decorator if you're not a fan of writing really long variable names. Okay, so of course, just for completeness, we can always access the variable directly. And one really cool thing is that once it's run, the values are cached, like the results of a node run are cached with the node. So calling this, if it's a computationally expensive node, this will save you time, save you compute, essentially, because it remembers that it's already run this node, so there's no need to call it again. Okay, so onto the actual workflows. We can create a workflow object by simply calling the workflow object that we had defined at the very beginning of the notebook. And we can name, we can now assign this workflow various nodes. Here I'm just going to assign the Hooke's law node, the Hooke's law name attached to this workflow. And say after we complete the displacement, we would like to compute the strain on the object. It takes two variables, displacement and original length. Strain is equal to the displacement over original strain. And let's define an original length. Let's say 2. And we now assign this strain node to the workflow. So compute strain. And to basically assign the output of this first Hooke's law node to the displacement, we simply go workflow.Hooke's law.outputs.displacement. Okay, and this original length is original length. And to run it, we simply call workflow.run. Okay, so we can see that we get this workflow.run and it gives us the final output, and we can access any of the outputs on these nodes simply by going workflow.Hooke's law.output.displacement.value. Okay, 0.5 as we expect, and workflow.strain.outputs.strain. Yeah, strain is the output variable name, value, and we get 0.25. Okay, and one really neat thing, if you're really lazy, is you can basically go we define another workflow object, and go Hooke's law is this, so everything is the same. But if you know that this Hooke's law only outputs one particular output, we can do this shortcut right away. Okay, so we can basically cheat a little bit and say, this node only has one output, so there's only one possible access point for this displacement. And the workflow is smart enough to resolve that for itself. Run it again, we get workflow2.Hooke's law.output.displacement.value. Again, we get 0.5, and we can see that for workflow2.outputs.displacement.value. Sorry, not displacement, it would be strain. And we get 0.25 again. So these two are equivalent in the sense that if there's only one output on a node, there's a shortcut to basically say we don't want to type the whole thing out. And one final thing that's really useful is that you can draw your entire workflow graph. And zooming out a little bit. Okay, and we get this really nice workflow graph. All right, and that's it for your first workflow. Obviously, you can picture now how you can basically build these up to have many more complex connections and basically resolve really complex graphs. So tune in to the next part of the tutorial to learn how to do slightly more complex workflows.